Speaking of nuclear reaction, there are two kinds. First, fission reaction, splitting of heavy nuclei, and fusion reaction, the combination of light nuclei. Let's first talk about fission reaction. Fission reaction, also known as chain reaction. For example, I have a heavy nuclei, uran 235, and a neutron. Then I bump the neutron into a nuclei with high velocity, which will cause the uran to decay into a baryon, kryptonium, free new neutrons, and a bunch of energy. And because the neutrons are still moving, it can bump into other nuclei. That's what we call the chain reaction. And we can describe the reaction by this following formula. Top is mass, bottom is charge. By comparing the numbers from the left and the right, you can find out the total particle inside the nuclei are conserved. Which raises up a question. Why is there energy released when the particles are conserved? Let's have a look. First, we have two protons that have the same charge, which will cause a Coulomb force that's trying to push them apart. But wait a minute, that's not a nucleus looks like in an atom. Protons and protons should be tied up together, which means there will be a stronger force that's against the Coulomb force to push them together. But what is that force? Which is the strong nuclear force or the strong interaction force. Inside atom, there are nucleus and electron, but inside nucleus, there are protons, neutrons, and they are constructed with quarks. Every proton will have two up quarks and one down quark. Every neutron will have one up quarks and two down quarks. Inside them, the quarks will transfer in a particle called gluon, according to the law of quantum chromodynamics. And by that transferring process, quarks and quarks will tie them together just like string. And if you broke one of the string, all the potential energy inside the string will be released. That's why fission reaction is so powerful. There are a lot of things we can do with fission reaction. For example, we can build atomic bombs, making damage and explosions, or we can do something else like providing fission reactors to generating electricity and power to our city. Now it's time for fusion reaction. For example, I have a deuterium and tritium. When I let them collide head-on with each other, they will combine into a helium, releasing energy and a neutron. Also, we can describe this reaction by this following formula. We see fusion reaction everywhere. All the stars are experiencing fusion reaction process. Plasma are squeezed by the gravity confinement at the inner core of sun. People use fusion reaction to build hydrogen bomb. Fusion reactor is still a technical problem, but people still trying to achieve that by using strong magnetic force or high energy laser. China is building the Turkmen facility that's going to put into work at 2050. Can produce a high temperature at 50 million Celsius, controlled by magnetic field. Fusion energy is clean and powerful. It's the future of human energy resources. Let's work to the future.